All right, so here with 49, or starting with 49, we are now going to be combining everything that we've learned up to this point. So not only are we going to be factoring, but we're also then going to be finding the solution. So once we have factored our polynomials, we're then going to set each factor equal to 0. So let's start with 49, and we'll rewrite it out to the side here. So m squared minus 7m plus 12 equals 0. All right, so first thing you want to do is make sure that all your terms are on the left-hand side and that your equation is set equal to 0. And that's the case here. It was already given to us like this, so thank you very much. Now we want to go through and ask ourselves those two questions that we were doing for most of the practice test. Is there a GCF here in this trinomial on the left-hand side? Nope, I don't see one. So question number 2, how many terms? Well, 1, 2, 3. With 3 terms, we know we're either going to be using the scissors method or the AC method or trial and error method. But because the coefficient in front of my squared term is 1, this is a, relatively speaking, easier polynomial to factor. So this is a trinomial, so we know it's going to factor into 2 binomials, and again equals 0. And we're dealing with m, so we're going to split that m squared up into m and the m. And now we're looking for factors of 12 that add to give us -7. Well, let's see, what are the factors of 12? Well, 1 and 12, 2 and 6, 3 and 4. So from this list, which factors can we add to get $-7? Well, we can't get a -7 out of 1 and 12, and we can't get a -7 out of 2 and 4. But 2 and 6 rather, but 3 and 4 we can, right? If each of these were to have a minus in front of them, -3 plus, because of this plus, now -4, well, that does in fact give us -7, doesn't it? And that's what we're looking for. So -3, and instead of cutting it off, -3, -3, we have our -4, -4. And so now we're working with the quantity m-3 and the quantity m-4 equals 0. So now we're going to set each of these factors independently to 0 and solve. So we have m-3 equals 0 and m-4 equals 0. And so now let's go ahead and solve. We'll add 3 to both sides, and that gives us m equals +3. Here we'll add 4 to both sides, and that gives us m equals 4. And there you have it. All right, so again, you want to make sure that all your terms are on the left-hand side and that your equation is set equal to 0. Once you have your terms on the left-hand side, factor just like we've been doing. So with questions 1 through 48 or what have you, whatever it was, 40, maybe it was 45. But you just want to factor just like you normally were factoring. So ask yourself those two questions. Is there a GCF and how many terms? Once you've factored your polynomial, well, now the factors are set equal to 0. And so set each of your factors independently equal to 0. So our m-3 we set to 0, and the m-4 we set to 0, and then just solve for the variable. And that's all you have to do. That's what it means to find the solutions by factoring. And what these numbers really are tell us that if we were to take the number 3 and plug it back into our original expression, we would find what makes this equation equal 0. Again, we can do that with either 3 or 4. All right, so there we have it, number 49. Let's take a look at 50. So they gave us x squared plus 13x plus 36 equals 0. All right, all of our terms are on the left-hand side, good to go. We're set equal to 0, good to go. So let's ask ourselves question 1, is there a GCF here? No, I don't see one. So question number 2, how many factors are there? Well, terms rather, 1, 2, 3. With 3 terms, we know we're either using the scissors method or AC, trial and error. But again, just like 49, because the coefficient in front of our squared term is 1, this becomes a more easily factorable problem. We don't really have to go through the whole process of scissors or AC. We know this is going to factor into a binomial, and again, equals 0. We're working with x, so let's go ahead and split that x up into x and x. And we want factors of 36 that add to give us positive 13. All right, well, let's take a look. Let's see. 36. Well, we have 1 and 36. We have 2 and 18. We have 3 and 12. We have 4 and 9. 5 doesn't work. How about 6? 6 and 6. And I think that might be it. All right, so let's take a look at this list of factors and which ones can we add to get to 13, positive 13. Well, we can't do that with 1 and 36. We can't do that with 2 and 18. Can't do that with 3 and 12. We can't do that with 6 and 6, but we can do that with 4 and 9, can't we? And if we want our factors to add up to positive 13, what does the sign of each have to be? Well, a plus 4 or a positive 4, and then plus because the last sign was a plus, and then a positive 9 does give us what? A positive 13. So we had a plus 4, so plus 4. We had a plus 9, so plus 9. And now that we've factored our trinomial and it's set equal to 0, let's independently now set each factor to 0. So x plus 4 equals 0. X plus 9 equals 0. And now we'll subtract 4 from both sides. We get x equals negative 4. We'll subtract 9 from both sides, and we get x equals negative 9. All right, and there you have it. And on the test, how can you check yourself? Well, again, take each of your solutions, plug it back into your original equation, and you should get a true statement. So when you plug in negative 4, you really should, the left side should equal 0, right? So that you get 0 equals 0. If you plug in negative 9, you should get 0 equals 0. All right, and we can go ahead and try that. Let's go ahead and test negative 4. So negative 4 squared plus 13 times negative 4 plus 36 equals 0. Well, let's see. Negative 4 squared is going to give us 16, positive 16. And now negative 4 times 36, or 16 rather, is going to give us, let's see, negative 4 times 13 is negative 52. So minus 52 plus 36 equals 0. All right, and if you add this up, you will get 0 equals 0. So we know that negative 4 is a solution. And you can do the same thing with your negative 9 as well. Plug it in, you should get 0 equals 0. And that's how on a test you can check yourself to make sure that not only did you factor correctly, but that you also, once you factored, you didn't make a little arithmetic mistake in your solving for the variable. All right, 49 and 50 in the back. Let's take a look at 51 and 52, I think. See you there.